Hello. We're going to talk about the use of our balances and also volumetric glassware. Both of these are important tools that you'll use throughout the semester. Also, besides the printed procedure in your lab manual, look at Chapter 2 of your text, Tools of the Trade. Using a balance is very important. Part of this course is learning how to make precise and accurate measurements, and balances are key to that. Correct usage and maintenance of a balance is a basic skill that's essential in any laboratory procedure. There's a tare button that you'll see on your balance, and use that tare button to zero the balance before weighing reagents. Balances are expensive. Chemicals are corrosive, so clean up any spills immediately. If you have questions or problems, please see your instructor. These balances cost $3,000 a piece if it's an analytical balance, for example. And the top loading balances aren't cheap either. So there are two types of balances that we'll be using: a top loader and an analytical balance. The analytical balance is the most important piece of equipment for quantitative work. With it, you can weigh to 1/10 of a milligram. That means out to 4 decimal places. It's very sensitive, and air currents can affect the measurement, so make sure that you close the doors around the weigh pan. Convection currents can also affect your mass determination. So if you have been drying reagents in an oven, be sure to cool them in a desiccator before using. Check also to make sure that the balance is level. The little bubble is directly centered. It's best to only use the analytical balance when necessary. The procedure tells you to weigh to the nearest 0.1 milligrams, use the analytical balance. If not, use a top loading balance. This helps us preserve the quality of the analytical balances. Top loading balances don't give us the precision and accuracy that an analytical balance gives us. They might only go to the 100th of a gram, possibly to 1 milligram, or even possibly less than those. They're used for weighing large bulk materials and large pieces of glassware. Speaking of glassware, you'll be using some volumetric glassware in this procedure throughout the semester. There are different types. On the left, you see a volumetric flask. And then you see two different types of pipettes: a transfer pipette and a Moore pipette. And finally, on the far right, you see a burette. It's important to note whether devices are TC or TD. A volumetric flask is a TC container, to contain. The pipettes and burettes are TDs, to deliver. And that means different techniques, procedures to be used for those. The type of burettes we'll be using are Class A, the highest quality. You'll have the barrel of the burette that's marked in gradations of 1 milliliter, with small lines, finer gradations in between those milliliters. Those each represent 1/10 of a gram, 1/10 of a milliliter, excuse me. And you can actually interpolate in between those markings to get out to 4 decimal places, to the 100th of a milliliter. There's some different parts of the burette besides the barrel. There's also the stopcock and the tip. The stopcock enables you to control the amount of flow of fluid from the burette. In the picture on the right, you can actually see a little air bubble. It's important to get the air bubbles out before you actually start any titrations. As long as the air bubble stays put, you're okay. But if it comes out during the titration, you'll be off error-wise by the volume that would have filled that air bubble. Different burettes have different tolerances. We'll typically be using a 50 milliliter burette. So always read your Class A burette to 2 decimal places. So for example, if you're reading the meniscus, which is that curved surface, it's definitely between the 20 and the 21, somewhere between the 20 and the 20 and a half markings. You can further look at somewhere between the 20.2 and 20.3 gradations. And it's not quite half, so let's call it 20.23 milliliters. 2 decimal places, 4 significant figures. When using a burette, always record your initial and final volumes. And even though you'll be starting with a burette quote unquote full, close to the 0 mark, you don't always have to get it on the 0.00 mark. Maybe it's 0.02, 0.04, 0.05. And that's okay. 0.12, anywhere in there, just so that you know where you start. Volume readings increase from top to bottom. So as you deliver, that final number that you read will give you, when you do the subtraction, the total volume that you've delivered. So as we said before, each line is 0.1 milliliters on a 50 ml burette. Read to 2 decimal places, with the last decimal place being an estimate, an interpolation on how close the meniscus is to the lines. Whenever you use a burette, you want to condition your burette with a solution to be used in it before you titrate. For example, you've washed out your burette, you've made it very clean, but you have residual water in it. So before, if you're going to use hydrochloric acid as your titrant, you take a few milliliters of hydrochloric acid, put it in your burette, turn your burette more or less horizontal, and twirl that burette around, coating all the surfaces. You probably want to do that a couple, 3 times, and that's to make sure that you've rinsed out all the pure water and you just have the hydrochloric acid solution that you want to titrate. Hence, your hydrochloric acid solution is not diluted by residual water in the burette. Always rinse well with water when all is said and done, and always store your burette with the stopcock open and the tip pointing up. This will help us keep the tip from becoming clogged. Once again, to practice reading a meniscus, get it at eye level. That's important. Don't be looking at it from an angle, in which case parallax comes into play. And so it's between 9 and 10, and it's very close to the 0.7. Maybe not quite there, so let's maybe read it as 9.68. Volumetric flasks are not to deliver, but to contain devices. Once again, they have different capacities. You go anywhere from 5 milliliters up to 1,000 milliliters. And actually, I've seen them with 4-liter volumetric flasks. And they're meant to contain a set amount of volume. So when using a volumetric flask, if you're dissolving a solid solute, for example, you want to add some water to the bottom of the flask, add your solid, swirl it to try to dissolve as much as possible, and you add water slowly until you get all the solid dissolved. And then you, as you approach the neck of the flask, you'll want to use a dropper or a wash bottle to slowly fill the neck of the flask to the mark. And so what we're trying to do is get the meniscus to sit exactly on top of the line. That line means that at the given temperature of the calibration, it will contain that volume to within the tolerance level. Stopper the volumetric flask carefully. Then you need to homogenize your solution. And a way to do that is to invert the flask 20 times. As you invert it, you'll see the air bubble that was in the neck go up to the top to the bulb, back and forth. It's that air bubble that's actually doing the mixing. Never store solutions in a volumetric flask. Pour them into a plastic or glass bottle. Never use a stir bar in a volumetric flask. Pipettes. Once again, they come in a variety of sizes. The traditional transfer pipette on the left was meant to deliver a set volume, and then there's the Moore pipette on the right where you can measure not exact, even number volumes. These are to deliver devices where you just deliver a known amount. You do not blow them out. There's a particular technique that you use when using pipettes. So first, check to be sure the pipette is free from cracks or chips. Make sure it's clean. Just as we conditioned the burette, you'll want to condition the pipette. You'll want to rinse it several times for the solution to be used. Check for air bubbles. Never blow out the last drop from the tip. You want to keep the pipette vertical and have the receiving flask at 45 degrees. You'll want to read about this procedure more in your textbook, and also look at other videos that show how to use actual use of a pipette. Never, as I said, never blow out that last drop from the tip. It's meant to deliver, not to contain. And if you use one of these fancy pipette bulbs, never leave the pipette in the collapsed position. Always store it fully expanded, because what will happen is it'll have that memory of being in the collapsed position, and it will stay collapsed and become worthless. Always use your forefinger, your pointy finger, on top of the pipette, as that gives you better control as you deliver the solution. So these are just a few tips about using balances in glassware. They'll be important to you throughout the semester. Practice makes perfect, or actually perfect practice makes perfect. Don't get frustrated at the beginning. You get better at it as you go along. Have fun in lab and be safe. Thanks for watching.